Hello, welcome to thedeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computer explorer and problem solver. So, today we're going to be doing a British Informatics Olympiad problem. It's 2004, round 1, question 3, and it's called Morse Code. And also how you can participate, viewers, is you can just write something in the chat if you have an idea or any alternate idea of how to solve it, or you can see where it's going or something. Yep. So let's start. So now let's start with a question. 2004 British Informatics Olympiad Round 1 Question 3. Morse code. The BIO have been receiving telegrams congratulating it on reaching its 10th anniversary. At least we think it has. The telegrams have been sent in Morse code and, unfortunately, the gaps between letters have been left out. In Morse code, each letter of the alphabet is replaced by a sequence of dots and dashes as follows. Every combination of between 1 and 4 dots and dashes is used, except for dot dot dash dash, dot dash dot dash, dash 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 dot, and dash 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 dash. Traditionally, dots were transmitted by a short note and dashes by a longer note, with pauses between different letters. That's why some mobile phones make the sound dot 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 dash dash dot 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 when receiving a message, since this is the Morse code for SMS. If the gaps between letters are missed out, messages can be ambiguous. For example, even if we know the message dash dot dot dash 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 dot is made up of 3 letters, it might mean NJG, dog, RMG, or XON. XMG or XON. Write a program which reads in a message, between 1 and 10 letters inclusive, and determines how many messages, with the same number of letters as the input, it might represent. How many messages might dash 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 represent if we do not know the number of letters in the message? That's for part B. How about dash dot dot dash 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 dot? And then part C, is it possible to come up with new ways of encoding the alphabet so that even when the gaps between letters are missing, messages are unambiguous? The size of such an unambiguous encoding is the total number of dots and dashes in the message containing each letter once. So, whoops, 1 second. So that was the question. Now let's start solving it. So for part A was for part A we've got to write some code for let's write some code for that, and so we'll first have to find out what is the Morse code for dog or whatever it is. So if it's dog, then so for example, if it's dog, then D is dash. One second. I'll write some. so it's dash dot dot 4D, and then O is dash dash dash, then G is dash dash dot. So it's dash dot dot dash 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 dot. So and we have to find what all things it could represent. For if it's 3 letters, we can just, for brute force approach, we can just look at so dash, which one starts with, which one of these starts with a dash? Well, there's B, C, D, G, J, wait, no, not J, L, N, and that. And then we'll do dash dot, and then dash dot dot. Wait, no. So, what we'll do is, I think we can use recursion. So, so I've got to put some spaces in between. If it's 3 letters, then that means about.
But you don't know it's 3 letters at the start, right?
You do, because dog has 3 letters. No, I'm using an example of dog.
Oh, okay, you're using the example.
So because it's 3 letters, let's do that and that. So that's one example, and that has 2. So we can use recursion to find these spaces points. And so for example, this would be dash dot is that's N, then dash dot, then that is J, and that's G, so it's NJG. So we can just use recursion to place those 2 everywhere, and then find all of them which actually work.
So what kind of recursion will be right here? What are the variables that we need to track here?
So we need to track we're going to return the number of that we found, so we don't need to do that, and we can do so we have to do the thingy. So if it's dog, then dog, I think. redo the text thing.
The input is just a Morse code, right?
What is just the Morse code?
The input is just the Morse code, right? You don't know if it's dog or NJG or XON or any of those things. You just know that the input contains this Morse code.
It says write a program which reads in a message between 1 and 10 letters inclusive, and for the subheron, it's dog. Determines how many messages with the same number of letters as the input it might represent. So
we need the same number of letters as well.
So I'm pretty sure that the message is just a normal text message.
Yeah, then we need to convert it to the Morse code,
Yeah.
and then we need to see how many strings can be made from it.
Yeah. So I'm not sure. Actually, I'm not sure that we need any variables. Because
We don't need any variables.
yeah, because we can assign just message is just dog or anything as a start, and then define func of and then yeah, but we will need to convert it to Morse code. So
converting it into Morse code is pretty easy, right?
Yeah. I think we need to store the at the start we could also do
So converting into Morse code, can you just quickly tell the steps for converting into Morse code?
So we can store a dictionary, which I think it's Morse trans. So Morse trans. Then so let's start with the first letter of the message, D, and then we'll to find what D is, and then add that with O, and then add that with G. And
we just concatenate the strings one after another.
Yeah.
Yes, right. So we get the Morse code pretty easily.
Yeah.
Now, how can we get the string back from Morse code?
So why do we need to get the string back from O? So to get the string back from the Morse code, just that's what this function is doing. So what we're going to do is actually I think we do need some variables.
So if you have this sample Morse code for let's say dog, it's dash dot dot. For O it is dash dash dash, and for G it's dash dash dot. So let's say we decode the string till let's say this part, the first two letters, these form n, right?
Yeah.
So now we just need to decode this part of the string, right?
Yeah.
So maybe we can write a recursion that takes this into consideration, that if we have decoded till I, we only need to decode after that.
Yeah. Sorry.
I need to have a glass of water. I'll just be back.
Just have a little break for a second.
Yeah, right. Hello?
Okay, so I think, so then, whoops. So, now I think what we need to do is, we need a variable, so which stores the amount that's left to decode. For example, if we decoded that as n, then it will store all of this.
Mm-hmm.
And
So instead of message, we can just track the index, right? I.
yeah.
So yeah, both of these are fine. We can use any.
So if I is the len of I think I'll call this MSG. MSG minus 1, then that means we've already done all of it, so
I think you should put so f of I represents the number like how many days if decoded till I, right?
yeah.
Does this make sense?
Not really.
We are writing func of I, right?
Yeah.
We are trying to write a recursive function. So what does that recursive function represent? Like what value will it produce?
The number of ways.
The number of ways, and what does I represent here? If we have already decoded it till ith index.
Then I represents the number that the amount that we've already decoded.
The amount it will?
That we've already decoded.
Yeah, exactly. I represents the amount we have already decoded, right? F of 0 means we haven't decoded anything till now.
Yeah.
So, what would f of n minus 1 mean? That we have decoded everything till n minus 1, but we still haven't decoded the n minus 1th index.
That means we've decoded every character except the last one.
Yeah, exactly. So that is not a correct basis, right? So can you like change this basis a little?
So,
Like greater than or equal to, yeah, both of these.
so next, sure. Then we'll to let's say we've already got a function to check whether whether we can do we can like we can split it into like this or that. So if we've got that, then if let's call that function g. If g of if g of I comma, and it'll take I and I plus 1 because and I plus 1 or I plus 2 or whatever it is. Wait, how about we can do I and just the width, which is it's going to take I and the width of it, so then it knows that, so it already knows the translated message, the Morse code message, so it can work out whether it'll work. So if g of I equal 1, then
what is exactly g of I?
G works out whether we can for example, for this method, G works out whether we can add another one here or here or here. Yeah.
Okay, it just tries to run through all the alphabets and it goes one step forward.
So GFix basically what it does is if we can do if we can add one over here somewhere, then it says 1, but if we can't add 1, because then it says 0. For example, over here we can't add 1 because dash 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 dot is knowing the alphabet thing.
Right.
Is too long, I mean.
So what we can do is when once we are at ith index, we'll run through all the alphabets and their representations in Morse code, and we'll see if the index from I to the I plus length of the Morse code we're looking at is like if the string in between matches or not.
Yeah, we'll code that later because we'll code that later. So right now we'll just assume we have an function. So then if u of I comma 1, then what we can do is just that means we can do it, so return func of I plus 1 and do the same thing for
It will be I plus k, right? K or something.
Yeah, it's same for I plus k up to, and we're going to do it up to 4. So do I comma 1, I comma 2, I comma 3, and I comma 4. And over here I plus 1, I plus 2, I plus 3, I plus 4.
Right?
Yeah. So just next. So just write that symbol. That just means that same thing 4 times, and we just
We can just write a loop which runs through all the alphabets. No?
I guess. So 4k in range of 1 to 4. Then what we can do is just if g of I comma k, then so we'll also have sum. That will be the total number that we've found. Sum equals 0. Sum plus equals the func of
I plus k.
yeah, I plus k.
Right.
And
Now are we missing something there? Like this solution is almost complete.
yeah, we need to do the code for g of x.
Hmm.
G of I comma width. So define g of x. Let's make it a little bigger. One second. Okay, so then what's so
G of x has I and k as well.
yeah.
Hmm.
So what we're going to do
we already have a dictionary which has alphabet towards most level.
I'm pretty sure we don't need the dictionary because it said in the question that that everything is used except for dot dot dash dash, dot dash dot dash, dash 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 dot, and dash 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 dash. So actually no, that won't work.
So what is the function of g of I comma k doing?
So it's just so it's finding out if we can actually it's basically finding out if we can add another space after 1 or after 2 or after 3 or after 4.
Yeah, so it basically just checks if
It checks if we can do it.
s of I to I plus k is valid or not. Valid Morse code.
Yeah. And it also checks if everything after I plus k, if that's less than or equals to 4, then it also checks if that's valid too.
So that can be handled through f, right? G can only be defined to just like if s to I equal to plus k is valid or not. We can handle all of that in using the function itself.
Okay. So if it's called, I guess it's called DSA. So if s of I to I plus k is in dic, then if that's in dic, then and that means we can do it, so return 1 and return 0.
Also, if you check it like this, if s of I to I plus k is in like it will take the keys, right?
In dic dot values.
Exactly.
I'm going to go get a tissue. Just 1 minute. So there you go. So also I think we need to make some changes to our function because it doesn't check whether we can do whether s of I plus k2 is valid or not.
Exactly.
So 1 second. So
Do you have any ideas for that?
So I think we can do if we can do just the
Okay, so let's look at how our f is performing, right? So if it reaches, let's say, n index, that means we have decoded behind n minus one, right?
yeah.
So anytime that we reach the nth index, we can say that our function is like working fine, and we have found out a successful way to decode the string. Now, if we are at any index behind n, and we are not able to get a valid configuration after that, we are not able to get any, let's say, none of the g is true after that, then we can just say that it's not valid, right?
Yeah.
So,
So we can just do g of I to g of I and len of message minus I.
g of I is?
It's just this function. So it's g of I and k is the length of message minus I.
I didn't get you.
So we can just do we can just use this function, but use len of message minus I instead of k.
I didn't get you, Patel. Okay, let's start writing the code. Let's see how we can correct it.
So, 1 second. Let's see. Find where's so first of all, define one second, I'm just gonna do that. Define font off, and then we're going to do this. So it has an index. If I is more than or equals to length of message, we'll set message should be and message is the Morse code version of that. So for example, for dog it's one second, let me check what it is for dog. Dot dash dot dot. One second, just there it is. Dash dot dot either more than or equal to the length of the message, then we can return 1.
It will actually always be equal to the message, so you can just one then.
Just turn 1 to 1.
Yeah.
So sub 0. 4k in a range of 1 to 4.
Sum is actually a keyword in Python, so you might want to change it to SN or something like that.
Yeah. Just do S. Then if G of I comma 1, if I comma K, then stop. So that's equals to of I plus K. And no, not some S. And it also change and when we carried G, then we'll also change. We'll also add. We'll also check whether I plus K is in the length message. And return some S. Yeah, now define G. I comma K. Not I comma K. Yeah, I comma K. And then, so what we can do is if S of I if I plus K is less than length message G. And I plus K, if that is in the tick dot values, and return 1, and then return 0, I'm not sure if we need it here, if we need it on the top one.
Return the values is a function. So you might want to correct that.
Is dot value. So I'll show us a list of the values. And we also need dick. Yes, must write that later. Okay, so I think that's it. Let's do func
So right now our dictionary isn't defined, right?
Oh yeah.
We need to add some elements to it. You can just add the important ones like D, O, G, N, all these ones.
So D. D. So D is
Maybe I'll help you with that. So D is dash dot dot.
D. 1 second. D is dash dot.
J is dot dash dash dash.
Dot dash dash dash.
N is dot dash dot.
Dash dot.
G is dash dash dot.
Dot. Okay.
X is dash dot dot dash.
Dash dot dot dash.
And O is dash dash dash.
O is dash dash dash.
And last N is dash dash.
N. N is dash dash.
Yep. That should be enough, I think.
Flunk of 0.
N is dash dash, not N.
So M is dash dash. Flunk of 0.
This. You need to write the function call as well.
Write that there. Print.
Okay, let's check. Yeah.
So it's there.
Wait, make it once.
I'm gonna try and print out I. And then let's look some messages. 1, 2, 3, 4, 5, 6, 7, 8, 9.
You can also check if your G is working fine. So maybe try printing the string between I and K and the result of G corresponding to that.
So print out. I'm pretty sure it doesn't. I plus K doesn't include I. It says dash dash dot dash dot dash.
Also, you need the result of G corresponding to that.
And point out 1. And also print 0 here. wait a second, no, because
Can you comment out printing 9?
so, let's try that. So dash is on there, and it's T.
Dot is dot dash is
T is that.
dash dot. Okay, looks like G is working fine.
And actually, T is dash. So, what is it? And the dots, I'm pretty sure I saw one which was a dot. E is a dot.
Yeah. But he is never a part of a solution, right? So we are just trying to get the. Otherwise, you have to write the dictionary. Okay, let's see.
Actually, I don't think we need the dictionary because we don't need the dictionary because all we can do is it said that dot dot dash dash. We can check if it's dot dot dash dash dot dash 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 dot or dash 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 because those are the only ones not in there. So if that's gonna help. And dot dot dash dash comma dot dot dash comma dash dot and dash if it's not in
Okay, G is anyway working fine.
it says for some reason that dot is not one, but it is.
So there is some issue with our function. G function is working fine. It was working fine. Did you change something?
Yeah.
Actually, you did this not thing.
I change it to this because those are the only ones which are not in there because the question says that.
Okay. Why is this not working well then?
Try something.
No, that way it was fine only in the list. This is invalid syntax. No? The previous way was fine. It should be I plus k is less than equal to length of message, by the way. Oh no, it should be length of message only. No.
Wait, I think this dot's not there because if I can put that I can't. Wait, I'm going to actually no, I'm going to print out. Type print out entered state.
Have you saved the file? I think this is an issue with saving the file or something.
I did save it. So, yeah, it's working fine.
Yeah.
Okay, so now it's definitely an issue with func. Wait, we haven't tried it. What was the output? 0 again.
Yeah.
Okay, so we can
Yeah. So you can remove all the print statements from the G function, I think. Yeah.
And I think we might still need printify. I forgot one. I think we should remove printify actually.
This means I is the sum is never getting incremented.
Yeah, so func of I plus k is just returning zeros. So I think that's because for one of them g of for one of them actually
Can you write print I under s equals to 0 and then keep on printing s after every iteration? That way we can get an insight into. Or just like put print I comma k in print I comma k here.
so print I
I comma k and s. Where you written print s, just put I comma k comma s. Okay, not read. Yeah, the S is never getting incremented for any values.
Thunk of I plus k is definitely returning 0.
Okay. So basically f of I plus a is not returning ones and all. Okay. This would be a case when we are not reaching the end.
Actually, I'm pretty sure that we are reaching the end because we are reaching the
Okay,
end.
I can see some 8s as well. So our message is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's not going till the end, right? You can't see any 9s here.
Yeah, but it does.
Yeah, it should be I plus a is less than equal to length of message. In G.
One says 149 now.
Because we have some output, right?
Yeah.
This is and no output. Okay. So we are basically counting some strings again and again.
It's 11:35 now, so roughly 11:37.
Oh, okay.
So should we continue or carry on next week or tomorrow, whenever we're doing the next session?
Yeah, okay, we can run through the code ones.
So should we stop streaming?
Yeah, sure.
And also, thank you for watching.